Everyone, first and foremost, I would like to thank Department of Physics, Namchi Government College and Sikkim University to provide this platform to make a video lecture on the topic transistor provided by our respected teacher Dr. C.P. Khatewal for the partial fulfillment of BSc third semester June to December 2020. This video carry 25 marks or sessional B examination. My name is Shrinyanki Bhutia, holding a roll number 19NS0126, and my topic is transistor. So, first of all, what is transistor? Basically, transistor is a combination of two p-n junction diode. It is three-layer semiconductor devices. So transistor is a combination of two p-n junction diode. When two p-n junction diode combine, there will be two options: n-p-n transistor and p-n-p transistor. So when P-type of semiconductor is sandwiched between two N-type of semiconductor, then this types of transistor is called NPN transistors. And similarly, when N-type of semiconductor is sandwiched between two P-type of semiconductor, then this types of transistor is called PNP transistors. So now, best efficiency is provided by this NPN transistor, because we all know that in the case of N type of semiconductor, majority charge carriers are electrons. Well, in case of P type of semiconductor, majority charge carriers are the holes. Electron charge carrier are best because mass of electron is very less as compared to holes. In NPN transistor, acceleration is high, but in PNP transistor, acceleration is less. And जुन पार्टिकलको एक्सिलरेसन लेस हुन्छ, then they are not better mobile charge carrier. Mobile charge carrier means mobility. Because of this less electron, because of less mass, electron have best mobility as compared to holes. That's why NPN transistor is widely used. Transistor is very special because there are three lines. One of them is emitter, base and collector. So this base line, sometime it will connect it with output input, or sometime with it will connect with output. Similarly, emitter can also connect with collector or base. In the same way, collector can be common with base as well as emitter. So there are different kind of possibilities are available with these types of devices. So here first emitter, second base, and third collector. So in construction of transistor, two factors play an important role. One of them is size and doping. So In emitter department, doping is very high, but in base it is less. At collector, uh, am, higher than base but less than emitter. Similarly, in at size, collector have huge size and base have small, but emitter have greater than base, smaller than collector. So it was the construction of semi transistor. Now the question is how to activate transistor. So how to activate transistor? Uh, there are three terminal. One terminal can common with input as well as output. So to activate transistor, so it should have EF, that means emitter should be in forward bias mode, and CR collector junction should be in reverse bias mode. So in emitter junction, doping is very high. In emitter junction, doping is very high. चार्ज क्यारियर मुभ गर्नुको लागि चाहिँ चार्ज क्यारियर मुभ गरेर चाहिँ त्यसले चाहिँ कन्स्टिट्युट करेन्ट कन्स्टिट्युट गर्छ, and to make a current or to move charge carrier, you have to put forward bias, because in forward bias easily electron can cross the junction and create a current, while in a collector junction less doping, so will be reverse bias mode. The symbol of the transistor. Now the symbol of the transistor. So symbol NPN transistor. So base is fixed, but emitter and collector you should pick anywhere. So here is emitter and collector. So this is a NPN transistor, NPN transistor. So the arrow will be like this because it always go positive to negative, plus to minus. And for PNP transistor, emitter, collector, base. This is PNP transistor. PNP transistor, the arrow should be like in upward direction because it's go P positive to negative. Now work of transistor. So here simple diagram of NPN transistor where it is emitter section, base section or collector. So it should NPN. Now it should connect in emitter size. We should always connect it with forward bias mode. We have given a voltage exactly equal to VEE, which is offering a forward bias voltage to this NPN transistor. This is positive and this is negative. VEE and this is VCC, which is offering reverse bias. Positive and negative. This and with connected with positive and opposite is negative, but in emitter junction it should be connected, it should be in forward bias, so that's why it should be connected with negative. And VEE is providing forward bias just because of forward bias depletion layer at emitter junction. Depletion layer at emitter junction gets short. Well, depletion layer become more at collector junction. Just because of VEE battery, under the influence of VEE battery, this minus will repel the electron. Because battery create electric field. Because of this electric field, electron experience a force due to VEE battery. Electron will move towards base and neutralize the holes. Remaining electron again move towards collector because the size of the base is very small, so it can move towards collector. And when electron reach at the collector, immediately start to repel each other, and under the influence of VCC battery, electron flow to positive terminal which are present in collector and create a current IC, collector current, which is denoted by IC. And here when electron moves towards base, also create a current also create a current IE, emitter current, which is denoted by IE, and electron set in holes because of negative tendency of electron. It always attracted by positive terminal. So uh, electron set in a base flow like this and create a current IB, base current. Now we will see the direction of current. We all know that current will also start with positive terminal to negative terminal. For input positive terminal to negative terminal, which is IE, emitter current, and for collector current positive terminal to negative terminal, that is IC, collector current. For base electron flow like this, then we all know current flow current flow in opposite direction like this IB, base current. Observe this point at junction incoming current equals to outgoing current. So incoming current is IE, emitter current, or outgoing current is IB plus IC. IB plus IC. So now transistor as an amplifier. So here amplifier is the circuit, while the amplification is the process. In the case of amplification, low intensity of sound is converted into high intensity of sound, and the device which performs is called amplifier. And amplifier, that means a type of transistor. So here is this is the transistor as an amplifier circuit. So to activate a transistor, base emitter junction, which is called emitter junction, should be in forward bias mode. Base is base, collector, emitter, NPN. So emitter junction should be in forward bias, so collector junction should be in reverse bias. Now this is base collector junction, so it should be in forward bias. So positive can connect it with positive and negative connected with negative. And for collector, it should be in reverse bias, so negative connected with positive and opposite is negative. So now there is on voltage between base and emitter. This is called base emitter voltage. Now there is base between base and emitter there is a voltage called base emitter voltage VBE. Similar situation, collector and emitter, and this is called collector emitter voltage, VCE. Suppose here is emitter connect, it is connected in base side, so which is measuring base current IB, or another emitter is connected at collector side, which is measure our collector current IC. So the direction of current should be positive, and this should also positive. IB base current, and it is collector current IC. So if you observe, both base current and collector current are incoming current. So here emitter current IE should be outgoing. The signal which has to be amplified is always connected between base and emitter. Suppose here is a signal Vs. When signal is added, then VBE is going to be changed, and when your input voltage is going to be changed, base current will also change. Base current IB is also changed. When base current IB is changed, then IC is also going to be changed. This change is about milliampere. Ultimately current increase. So the voltage drop is also increased. So we get the amplifier signal on the output side. So now transistor as a switch. So RL is load resistance, RB is base resistance. So BB battery providing forward bias, and BCC providing reverse bias. The emitter should be here because it has common with both input as well as output. Now the direction of current is always positive terminal to negative terminal. Input current IB and collector current IC is also positive to negative terminal. Start with positive, and if you observe, both are the incoming current, then emitter current IE should be outgoing current. So In transistor as a switch, we have two cases. One, whenever input voltage is less than cutting voltage cannot create IB current, because the voltage you offering the transistor is less than that potential barrier types of voltage. When IB equals to 0, then there will be no IC current and output voltage is exactly equal to VCC, and this stage is called off stage of transistors. And second, when input voltage is greater than cutting voltage, the IB is going to be increased, then ultimately IC is also going to be increased. After increasing IC at certain period, it become constant, then output become 0. Is a two cases of transistor as a switch. So now transistor as a switch. Here is the circuit diagram of transistor as an oscillator. So here is a base, collector, emitter and NPN with direction downward direction. So connected with VEE battery, emitter and base connected with VEE battery, which provide forward bias, and collector connected with VCC, which provide reverse bias. And now at the input side between base and emitter, you have connected one inductor and one capacitor in parallel to create electromagnetic wave. So when key get tapped, IC collector current start to flow. Because of this positive sign, IC is going through inductor L2. This line showing a mutual induction. At inductor L1, flux is going to be changed. The change flux is reached at L1 inductor by mutual induction, then change flux in L1 inductor and create EMF, which is called self-induced EMF. र त्यो EMF ले क्यापेसिटरलाई चेन्ज गर्नु सुरु गर्छ. देन अप्पर प्लेट पोजिटिभ हुन्छ र लोअर प्लेट माइनस. And ultimately forward bias voltage get increases. This capacitor and this VEE battery both are giving plus to forward bias mode. So ultimately forward bias mode increases. Then IB also increases. IB is also increases. When IB increases, then IC is also going to be increases. it means capacitor get full charge. Sorry, IC is also going to be changed, increase up to saturation. Up to saturation means, it means capacitor get fully charged. When capacitor get full charge, they cannot create EMF. And now when capacitor get fully charged, the IC current cannot create EMF, and now capacitor get discharged itself. When it get discharged itself, then it should be here minus and plus. Upper plate will be minus and lower plate will be plus. So in this case, forward bias will be decreases, and when forward bias decreases, IB base current also decreases. When base current is decreases, ultimately IC also decreases up to cutoff stage. Up to cut off stage. When capacitor get fully discharged, then repeat the same process. It will capacitor again यो capacitor फेरि रिपिट भएर चार्ज हुनु थाल्छ, then सेम प्रोसेस रिपिट भएर